Okay, so we're up to organic molecules 3. So for this syllabus outcome, it's going to be more of the nomenclature stuff. But today we're also going to talk about carboxylic acids, amines, and amides, as well as a few of the other things as well. Now, revision. So substituents are atoms attached to the parent chain. They can include halogens and other carbon chains, so methyl ethyl groups. Alcohols have an OH, so a hydroxyl functional group. Aldehydes have that carbon-oxygen functional group, which we call a carbonyl, at the end of the parent chain. Ketones have that carbon-oxygen carbon functional group elsewhere in the molecule, so not the terminals. And we also have things like, so alcohols are called alkanols, so ethanol, methanol, propanol. Aldehydes end their name in anal, so ethanal, propanal. And ketones end theirs with anone, so propanone, butanone. So let's have a look at carboxylic acids. Carboxylic acid functional groups contain a carbonyl group as well as a hydroxyl group attached to the same carbon. It ends in anoic acid, so ethanoic acid, propanoic acid. It's always carbon number 1. Okay, so wherever that carboxylic acid is, that is not carbon number 1. Now, the H on the OH is acidic and can be easily donated. That's why it's called an acid, because that OH, the hydrogen on the OH is very labile. It's very easily moved. Now that's a picture of it. So that's the carbon-oxygen double bond with the OH attached. So wherever you see that functional group, that is a carboxylic acid, and it's always that carbon that's attached to the carbon-oxygen double bond, so that actual carbon in that double bond is carbon number 1. So there will never be any other substituents on carbon number 1 because there's not enough bonds. So name the following. So we follow our same rules. What's our first rule? Find the longest chain. Boom, 3. So it's prop. What functional group's there? Oh, look, it's a carboxylic acid. So we've got carbon-oxygen double bond with an OH attached. So the longest chain is 3. No substituents. Functional group is a carboxylic acid, so it's going to be propanoic acid. Nice and easy one. What about this one? Again, we follow the same rules. Find the longest carbon chain. There's 5. We have a carboxylic acid and we have an iodine. Now, the key thing to remember, our carboxylic acid will always be number 1. So what carbon is that iodine on? Count them. It's 4. Okay, so let's put it all together. Longest chain is 5, so it's pent. There's a carbonyl and a hydroxyl on the same carbon, so it's pentanoic acid. One substituent that is an iodo group, and it's on carbon 4. So it's going to be 4-iodo pentanoic acid. Now remember what I said last lesson, acids are the only ones that can have that space. So it's a pentanoic acid with a space in between. Now, name the following compounds. Same deal, find the longest carbon chain. Count them. 1, 2, 3, 4, 5, 6. There's a carbon-oxygen double bond with an OH, so it's hexanoic acid. We have a chlorine and a fluorine. Let's put it together. Longest chain is 6. Carbonyl and hydroxyl on the same carbon, so it's hexanoic acid. There is one chloro substituent on carbon number 3. There is a fluoro substituent on carbon number 2. Now, how do we put it together? What was our main rule? It was alphabetical order. So we're going to put 3 chloro, 2 fluoro, hexanoic acid. So even though the bigger numbers first, with chloro, it's in alphabetical order, and that was what was more important when we're writing down the name. Okay, so 3 chloro, 2 fluoro, hexanoic acid. Amines. Now, amine functional group is called an amino group. It's written as an NH2, very similar to OH with a few slightly different chemical properties. Molecules that contain that NH2 end in enamine. And due to the presence of the NH2, hydrogen bonding can occur. Therefore, amines are usually soluble in water. So name this compound. Following the same rules as always. Start with the longest chain. It's 2. Nice and easy. We can see that there's an NH2 and there's nothing else. So this is going to be nice and simple. Longest chain is 2 carbons, sorry. It's eth. It contains an NH2, so it's enamine, so it's ethanamine. Numbering doesn't matter for this particular compound just because there's nothing else there. It will always be number 1. And there's no substituents, and so therefore the name is ethanamine. Okay. Now, this one. Longest carbon chain, 4. It has an NH2. The only other thing is a fluorine. So, longest chain is 4, so it's going to be bute. There's an amine, so it's going to be enamine, butanamine. The amine is on carbon 1. One substituent that is a fluoro, so it is on carbon number 2. And so therefore the name is 2-fluorobutane-1-amine. Okay, so remember the number for our functional group, we always put it after the an, so an-1-amine. And it's important that we number where the amine is. Here's another example. Count the longest carbon chain. 7. Hold on. 1, 2, 3, 4, 5, 6. Yes, 7. It's got an amine and a chlorine group. Now, how are we going to number it? So the longest chain is 7 carbons, so it's a hept. There's an amine, so it's heptanamine. Now, we need to figure out which carbon, which way are we going to number it. So we can number it with chlorine on the 2 and the amine on the 5, or the amine on the 3 and the chlorine on the 6. Now, the rule was, when there's a functional group, the functional group needs to have the lowest number. So that basically means that the amine, it can be on 5 or it can be on 3. Which one's the correct one? Well, it's the 3. So in this case, the amine is going to be on carbon 3. That means we have a chlorine on carbon 6. So it's going to be 6-chloroheptan-3-amine. Now, amides, again, something slightly different in naming, completely different in chemistry. So the amide is a functional group that contains a carbonyl group with an amine group. Amides end in anamide, so propanamide, ethanamide, that sort of thing. It's always carbon number 1, just like a carboxylic acid. And the H on the NH2 is very weakly acidic. It's about as weak as water. Okay, so it can be donated, but it's not as easily donated as a carboxylic acid. Now, name the following compounds. So this is one. Again, find our longest carbon chain. First step, always find your longest carbon chain. Now, we have a carbonyl with an NH2. So this is our amide group, and that's going to be carbon number 1. In this case, we don't need to number anything else, but remember that one will always be number 1. So it's going to be F, carbonyl with an NH2, so it's an ethanamide. No substituents, so it's literally just ethanamide. Okay, remember, because it's always carbon number 1, we don't have to number it. What about this one? Find the longest carbon chain, which is 5. Okay, it contains the amide group. It also contains a methyl group. So how do we number it? How do we name it? Longest chain is 5 carbons, so it's pent. It's an anamide, because it's got that carbon-oxygen double bond and an NH2. There's one substituent that is a methyl group. which carbon's it on? Well, the carbon in the in the amide functional group starts at number 1, so it's on number 2. Therefore, the name is 2-methylpentanamide. Lastly, 1, 2, 3, 4, 5, 6. So it's going to be a hex. And there's our amide group. So it's hexanamide. So look at the the substituents that are attached. We have 3 fluorines. So our longest carbon chain is 6, so it's hex. It contains that carbonyl attached to NH2, so it's an anamide. 3 fluoros, but what numbers are they on? Well, the carbonyl, the amide group that contains the carbonyl is always number 1. So there's 1 fluorine on carbon number 2, 2 on number 5. So it's going to be a trifluoro. It's going to be 255. So 255 trifluorohexanamide. Now, summary. Carboxylic acids contain carbonyl group attached to an OH and end in enoic acid. Amines contain an NH2 and end in anamine. And amides contain a carbonyl group attached to NH2 and end in anamide. Amines and amides can also have other chains attached to the N. I think I forgot to put it in as a slide, but we call it N-alkylation. If we have something else, if we have another carbon chain attached to the N, rather than numbering it, so rather than having like 2-methyl, it would become N-methyl, ethanamide, or whatever, ethanamine. You could have N-methyl hexanamide, which would be a hexane, so 6 carbons, a nitrogen, then 2 more carbons. Okay. And so that's it for today. Thank you very much.